Hi everyone, today we will learn about factorization, and today in special way we are going to learn about the factorization of polynomials. Now what are polynomials? If an algebraic expression has two or more terms, then it is called a polynomial. A quadratic expression ax square plus bx plus c is also a polynomial because it has three distinct terms. A polynomial can be expressed as a function of its variable. Like in this case, as we all know, x is the variable, a is the coefficient of x square, b is the coefficient of x, and c is a constant term. So this can be written as a function of x. So any polynomial can be expressed as a function of its variable, in this case as a function of x. It is written as fx. It can also be written with another letter, say for example gx, and suppose gx represents 2x plus 3. So this is another polynomial. In general, the polynomial can be written like this: a naught x to the power n plus a1 x to the power n minus 1 plus a2 x to the power n minus 2 plus, and eventually if it has a last term, then it can be written as a n minus 1 x plus an. So this is the first term of the polynomial, this is the last term of the polynomial. Here n represents the degree of the polynomial. N represents the degree of the polynomial. In this case, the degree of the polynomial n is equals to 2. That means a quadratic equation has degree 2. Now, let us try and understand the division algorithm. We know, suppose for example, you have 6 divided by 2, then this 6 is called the dividend and 2 is called the divisor. Then when we divide 6 by 2, then we get 3 times 2, 3 is 6. Then this 3 is called your quotient and 0 is called your remainder. Now what is the division algorithm? The dividend is always equal to the product of the divisor and the quotient added to the remainder. So if we take the product of divisor with quotient and add it to the remainder, then we will get the value of the dividend. Now here we know the value of dividend is 6. Let us verify whether it's true or not. So what is the divisor? Divisor is 2, quotient is 3, remainder is 0. So we get the answer 6, which is same as the dividend. This is called the division algorithm. Now, since C is completely divisible by 2 without leaving any remainder, or the remainder is 0, then 2 and 3 are called the factors of 6. So these two are what? Factors. 2 is one of the factors and 3 is the other factor of 6. If we write 6 as the product of its factors, then this process is called factorization. Now the question is, can we extend this rule to polynomials? Let's see. Let us consider two polynomials. First one is fx is equals to 5x square minus 7x plus 4, and the other one is gx is equals to x minus 2. Now, can I divide fx by gx and see what will be the remainder? X minus 2 divides 5x square minus 7x plus 4. So I have to get here 5x square. So if I write here 5x, then 5x into x will give me 5x square. Minus into plus, minus 5 2s are 10x. When we subtract, the signs get interchanged. So 5x square minus 5x square cancels. Plus 10x minus 7x will give me 3x, and plus 4 is already there. Next step, I need to get 3x here. So if I write plus 3 here, then I'll get 3x. Plus into minus is minus. 3 2s are 6. Again, when we subtract, the sign gets reversed. 3x minus 3x cancels. Plus 4 plus 6 is equals to plus 10. So here we get the remainder 10. Now, we know this is the dividend. This is the divisor. This is your quotient. And this is your remainder. So according to the division algorithm, the dividend must be equal to the product of divisor and quotient added to the remainder. So 5x square minus 7x plus 4 will be equals to x minus 2 multiplied to 5x plus 3 plus 10. So if you evaluate this one, we will get the same value. That means the division algorithm holds for polynomial also. Let us take one more situation in which fx is 2x square minus 11x plus 5 and gx is equals to x minus 5. Let us try and divide fx by gx. So first I need to get 2x square here. I already have x here. So if I write 2x, then 2x into x will give me 2x square. Now we need to multiply with 5. So minus into plus is minus. 2 5s are 10 into x is 10x. Again, when we subtract, the sign gets reversed. Plus 2x square minus 2x square gets cancelled. Minus 11x plus 10x will give me minus x, and plus 5 is already there. Now I need to get minus x here. So if I write minus 1 here, then I'll get minus x. Minus into minus is plus. 5 into 1 is 5. When I subtract again, the signs gets reversed. Now minus x and plus x cancels. 5 and minus 5 also cancels. The remainder is 0. Now, as you can see, this is your polynomial fx, which is the dividend. This is your polynomial gx, which is your divisor. We can see here that the quotient is also a polynomial. We can write this one as qx, suppose, and the remainder can also be written as rx. So in terms of polynomials, the division algorithm can be written as fx is equals to gx into qx. That means the divisor into quotient plus the remainder Rx. One more thing, since the remainder in this case is 0, then gx, which is x minus 5, and qx, which is 2x minus 1, are the factors of fx, that is 2x square minus 11x plus 5. So here we can write 2x square minus 11x plus 5 is equals to x minus 5 into 2x minus 1. So we have written the algebraic polynomial as the product of its factor. So this is factorized. Now the question is, what if the number of terms keep on increasing? Then getting the factors by division will become a tedious task. Or in other words, can we find the remainder, or can we verify whether this polynomial is a factor of the given polynomial or not without actually dividing? Yes, we can. That we will learn in the next video.